9 to 12 hours a week, every week of the year, he must connect his blood vessels through this set of tubing. His blood is routed through the tubing, which is immersed in a bath of fluid very similar to the blood plasma. Substances present in the plasma, but not in the fluid bath, tend to diffuse out of the tubing. The ability to maintain stable, uniform conditions within the body is vital to life. This stable, uniform state is called homeostasis. There are a million individual living cells within the human body. To maintain homeostasis in this environment, it is necessary to fulfill the basic requirements of each one of these cells. Each cell has the same basic requirements. Let's isolate a single cell and examine the systems that the body uses to fulfill these requirements. The cell lives in a surrounding medium of interstitial fluid, which is 90% water. This fluid is constantly in circulation, flowing in and out of our bloodstream. When this interstitial fluid is inside a blood vessel, we call it plasma. Food and oxygen come to the cell from the blood. Carbon dioxide and wastes exit the cell and are carried away in the blood. Our respiratory system adds the oxygen to the bloodstream and removes the carbon dioxide. The respiratory system maintains the proper homeostatic balance of these two gases within our bodies. This leaves food and wastes. The food is added to the bloodstream in proper balance by the digestive system. But what about the wastes? If they are not removed, the bloodstream becomes increasingly polluted. The balance is lost. Homeostasis is lost. Death will result. Let's add a waste disposal unit to the bloodstream. Now, homeostasis is brought back. This person is actually getting his blood cleaned. Without dialysis, the pollutants accumulating in his body would soon impair the functioning of his cells. His only alternative to regular dialysis is death. Most healthy people don't really need to worry about homeostasis. They don't need dialysis machines because they have healthy kidneys, which are constantly filtering their blood plasma. The kidneys are the main organs of the urinary system. The wastes removed from the blood are excreted from the body as urine. But the kidneys do more than just remove waste. The cells of the body require that there be a number of other vital substances in circulation in the blood plasma. The kidneys regulate just how much of certain substances should remain in or be removed from the blood plasma at any given time, based on the body's needs at that particular moment. The urinary system is located in the lower portion of the abdomen. The two bean-shaped kidneys lie on either side of the vertebral column. The urine exits the kidneys and moves down the two ureters to the urinary bladder, which rests on the floor of the pelvic cavity. The urinary bladder stretches as it fills with urine, stimulating within the brain the need to urinate. Releasing urine from the bladder is under voluntary nervous control. The urine leaves the urinary bladder and exits the body through the urethra. In males, the urethra channels the urine through the penis. In females, the urethra ends in an opening just in front of the vagina. Every day, our body excretes about 1 liter of urine. The urine is the end result of the kidney's filtration of the 13 liters of fluid which make up the environment in which our cells live. At any one time, 10 liters of this fluid is interstitial fluid, circulating between the cells. The other 3 liters are plasma flowing inside blood vessels. In the form of blood plasma, this fluid circulates through the kidneys many times each day. In fact, a total of 950 liters of plasma passes through the kidneys each day. A volume of this size represents a major portion of the total blood supply. At any given moment, 1/4 of the blood pumped out of the heart is being routed straight to the kidneys. To handle this much blood, the kidneys are supplied with fresh blood through the 2 large renal arteries that branch from the descending aorta.
רואים כמה הרן הארטרי
Veins
קצר,
return blood from the kidneys
שיוצא
to the
ישירות
inferior
דרך
vein
אבי
cava.
העורקים והכליות קרובות אל הלב כדי לשמור על לחץ.
There are 3 basic parts: the cortex, the medulla, and the pelvis.
אגן הכליה.
The pelvis is a large chamber which funnels the urine from the medulla out to the ureter. The renal artery and vein branch out into trees of smaller blood vessels, which carry the blood to and from a dense tangle of capillaries that spread throughout the medulla and cortex. This is where the cleansing work is done. Intermingled with the capillaries is a complicated array of tubing. Together, these tubes and capillaries are forming nephrons, the working units of the kidney. The nephrons are responsible for every aspect of urine formation. As the blood flows into the cortex, it is routed through capillaries that have formed into tiny coiled tufts. These distinctive tufts of capillaries are called glomeruli. Surrounding each individual glomerulus is a tiny sac of tissue called a glomerular capsule. Each of these glomeruli and capsules mark the beginning point of a single nephron. There are between 1 and 3 million nephrons in each of our kidneys. Let's isolate a single nephron along with its associated blood supply. The first part of the nephron is the glomerulus. Surrounding this tuft of glomerular capillaries is the glomerular capsule, which connects to the tubule. The tubule is divided into the proximal tubule, the loop of Henle, which can be quite long in most nephrons, and the distal tubule. Finally, the tubule is connected to the collecting tubule, which carries urine away towards the pelvis. Let's follow the blood.
זו תמונה נהדרת לצלם אותה, תסתכלו, הנה הרן הארטרי, ממנו יוצא עורקיק, מתפצל הנימים כאן, זה הגלומרולוס מסביב קופסית באומן, ופעם ראשונה בגוף שמהנימים יוצא שוב עורקיק, מתפצל פה לנימים שעושים חילוף גזים לנפרון, ואז יוצא ורידון שנכנס אל הרן הלווין חזרה. בצורה כזאת, מדהים לראות את זה, זה יפה.
Plasma into the nephron to see just how it works. From a thin branch of the renal artery, the blood enters an arteriole, and then enters the glomerulus. This is where filtration occurs, the first of 3 processes used in the nephron. The walls of the glomerular capillaries are 100 times more porous than those of other capillaries in the body. Fitting closely against them is the wall of the glomerular capsule, which has filtration slits in it. These 2 layers, which are each only 1 cell thick, act like a sieve, allowing any substance below a certain molecular size to leave the blood and enter the glomerular capsule. Blood cells and large protein molecules are about the only things that cannot cross this filtration barrier. Nearly all the plasma can pass through it. This filtration process is a form of passive transport. The cells forming the filtration barrier do not use any energy, moving substances from the bloodstream into the glomerular capsule. We can demonstrate glomerular filtration in this microscopic view of a living frog kidney. Here is the position of a glomerular capsule around a glomerulus. We will inject 2 different dyes into a frog's bloodstream. The first dye is made up of large molecules. The dye remains inside the glomerulus. The second dye is made up of small molecules. The dye fills up.
ראיתם איזה יופי? לקחו גלומרולוס של צפרדע והסתכלו מה קורה. שמו פעם אחת חלבונים גדולים בתוך התמיסה, ימצבו ביוד, לא עובר. קטנים עוברים, כי המסננת הזאת היא לפי שכל. בואו נראה את זה שוב, תראו.
Of the glomerular capsule, crossing the filtration barrier. Here it is a second time. Large molecules,
נתקעות.
small molecules.
עובר הכל.
The fluid that has passed into the glomerular capsule is called the filtrate. At this point, it is still very much like plasma, and still a very long way from being urine. From the glomerular capsule, the filtrate moves into the proximal tubule. Here, the filtrate will become more concentrated because of the second of the three processes used by the nephron. Reabsorption. Since the glomerular filter, according to size alone, even substances our body needs get filtered out of the glomerulus. They need to be reabsorbed out of the tubule into the...
זה מה שרציתי שתראו. אוקיי.